Good afternoon. Today we are going to see some problems of exercise 1 unit 5 and exercise 2 some problems in this video. So now first we will go with the third problem of uh, exercise 1 from unit 5. We have figure shows the cross section of simply supported beam when it is loaded with UDL of 50 kilonewton meter. It deflects by 10 millimeter. Find the safe load if this beam is used as a column with both ends fixed. Assume a factor of safety 4 and E equal to 200 GPa. So now first we have to find the span because span is not given. So we will write the given data first. So we have given a beam and L with the span of the beam. And we have given UDL on this beam. That UDL is 50 kilonewton meter. So we have 50 kilonewton per meter. This is L. Then you can see what data is given. So we have given. So I will write given data. So now we have given delta is equal to 10 millimeter. That is at center. Then we have given both end fixed as condition. Factor of safety is given 4 and E is given 200 GPa. So 200 into 10 raised to 3 MPa. Now if calculate Ixx of this, then we have Ixx equal to 300 into 1100 cube by 12. So we are going to consider a whole rectangle first. This is 300 and this is 1100 cube by 12. We will subtract these two parts from this. That is B will be 280 into 1000 cube by 12. So from this we will get value of Ixx and that is 9.94 into 10 raised to 9 millimeter to the power 4. So this is our value of Ixx. Now for column we have to go minimum and we have minimum that is Iyy. So for beam we have to take Ixx and for column we have to take minimum of the two that is Iyy. And therefore we will also calculate Iyy is equal to it is symmetrical with y-axis and therefore that is equal to 2 into 50 will be the width. 2 means we have two flanges. This is one flange, this is second flange. B 50 into 300 cube divided by 12. This is of flanges plus B we have for web 1000 and D we have 20 cube by 12. And this will gives us value of Iyy 225.67 into 10 raised to 6 millimeter to the power 4. So we have these values of Ixx and Iyy. Now we have for UDL maximum deflection will be at center and formula we have delta is equal to 5WL4 upon 384 EI. Now value of delta, this is given 10. So we have 10 is equal to 5. W we have 50 kilonewton per meter and Newton per millimeter will be same into L4, that L we have to find out, divided by 384 E is given 200 into 10 raised to 3, and we have this as our XX, that is 9.94 into 10 raised to 9. And if you solve this for L, then from this we will get value of L, that is equal to 13219.65 millimeters. So we have this will be the span. By using this span, we are in position to calculate the value of safe load. Now we will go with P E is equal to pi square EI minimum now upon L effective square. Now you can see we have given both end fixed. So now we will go with PE is equal to pi square. E we know that is given 200 into 10 raised to 3. I minimum is I by y. That value is given 225.67 into 10 raised to 6. And as we have both end fixed as end condition, so L effective will be half of this. So 1319.65 upon 2 whole square. And this value, if we will calculate, then we will get this value 6609.82 square. And from this we will get value of PE, that is equal to 10195.84 into 10 raised to 3 newtons. And that is equal to 10195.84 kilonewton. And we have P safe is equal to PE divided by factor of safety, and PE we have 10195.84, and factor of safety is given 4, and from this we will get P safe is equal to 2548.96 kilonewton. So this is our answer for safe load for the given cross section. Then we have second problem. A hollow cylindrical cast iron column 4 meter long, both end fixed. So we will go given data. L is given 4000 millimeter. Now both end fixed. L effective equal to L by 2 equal to 4000 by 2 equal to 2000 millimeters. Axial load is given P safe, and that is equal to 250 kilonewtons, and small d is given equal to zero point 0.8 into capital D. So now we will start it. So using actually not Rankine's formula, so we have to use this for Euler's formula, because end conditions are given, and Rankine's constant is also not given. So we have to use Euler's formula and adopt factor of safety 5. So first we will find PE is equal to P safe into factor of safety, and that is equal to 250 into 5, which will be 1250 kilonewtons. Then we will use formula P equal to PE equal to pi square EI divided by L effective square. Now we will put the values 1250 into 10 raised to 3, and that is equal to pi square. E actually is given 125 GPa, so into 125 into 10 raised to 3, I we have to find out divided by L effective is 2000 square. Now we will put I also over here. So this 10 raised to 3 gets cancelled. So 125 we have this value that is equal to 10, and from this we will get I is equal to 10 into 2000 square. Now put a value of I as pi by 64 d4 minus d4, which is equal to 10 into 2000 square. Then we can have d4 minus 0.8 d4, and that is equal to 64 into 10 into 2000 square divided by pi. And then if we will take d4 common from this, we have 64 into 10 into 2000 square divided by pi into bracket 1 minus 0.8 to the power 4, and from this we will get d is equal to 108.75. So that is approximately 109 millimeters. And a small d we have zero point 0.8 into 1 into 109, 87.2 millimeters. So likewise we have to solve this first problem from exercise 2. Then we have second problem that is little bit similar with first problem. So we have given over here, so 30 kilonewton per meter. So we have UDL on a beam, and we have this as 30 kilonewton per meter. Now span is given 6 meters, and then delta given data as shown in figure, and delta is given 15 millimeters. Now same formula we will use. Delta is equal to 5 by 384 WL4 upon EI. And if we will put values, therefore 15 is equal to 5 upon 384 into W is 30, L we have 6 to the power 4 upon, sorry, 6 we have 6000 to the power 4 upon EI. And if you will solve this, you will get value of EI that is equal to 3.375 into 10 raised to 13 Newton millimeter square. Now knowing value of EI, we can find P is equal to pi square EI upon L effective square. Now you can see we have pi square. EI is given 3.375 into 10 raised to 13, and L effective we have one end fixed, other hinged. So 6000 divided by root 2 whole square, and that will gives us value 18505 18505.86 into 10 raised to 3 Newton. So we have PE is equal to 18505.86 kilonewton. So likewise we have to solve the problems of the exercise 1 and 2. Remaining problems we will see in the next video. So thank you.